Okay, so I think a lot of you found this worksheet to be kind of challenging. I got a lot of, I'm confused. So I think what I'm going to start doing is I'm going to start sending you the correct answers the next day. Probably in an email, I'm not sure how yet. But this idea that you guys aren't getting feedback on whether your answers are right or not is kind of driving me nuts. So we have to do something about that. So anyway, so number one, big question was, where did the 7 come from? That was a lot of the questions I got today. So I need a height, right? Whoa, sorry, this is really not easy to go up and down. I have a problem going this way, I don't know why. Okay, so this is the height for this triangle here, whether it be this small triangle or a larger triangle like this. This is the height. They don't give me that measurement exactly, right? They don't say, hey, by the way, this triangle's height is this. So I have to figure out what it is some other way. So I'm looking for a distance from here to here. Well, I know what the distance is from here to here, right? That's 16. Right there, 16. Okay. Maybe I'll split that. But I don't need the whole height. I only need part of it. I only need the part that goes from the base of the triangle to the peak of the triangle. So to find that, I have to find the difference between here and here, right? The difference between here and this, okay? And to find that, you take what you know. And remember, I'm going to draw this line across here again. Remember, opposite sides of a square, and we know this is like a square or a rectangle because it tells us these are two right angles. So these two opposite sides are equal. So that means this is 9, okay? So to find this length here, I have to do 16 minus 9 equals 7. That's where that 7 came from. So this height is 7. So you're going to notice a lot, they're not going to give you directly the measurement. You're going to have to glean that from the information they do give you. And the knowledge of opposite sides being the same measurement, that is crucial, okay? You have to know that. Also, you need to remember that you're going to be finding that difference a lot. So that's a subtraction problem, okay? So that's where that 7 came from. All right, and I chose in mine to find the area of this triangle and then do this trapezoid. You could have easily found the area of this triangle by figuring out the base was 2.2 plus 8. So this was 10.8. And then finding the area for the whole triangle and then this rectangle down here. Another way to do it, okay? There are several ways to do all of these problems, okay? At least 2, sometimes more. Okay, this triangle, this shape here, when I was working with students today, they all wanted to go like this. Break it up like this. So you have 3 rectangles, okay? These 2 being equal with each other. So if you find the area of one, you know the area of the other, and then I can find this, okay? My preferred method for this, another method you could do would be to, I just want to get rid of those lines, would be to do this right here. Break these into 2 smaller triangles, and then I have 2 triangles that are 18 by 8, right? If these 2 are the same, 18 by 8, because that goes from here up. And then I have this 35 by, and then I would have to find the difference again. The whole side is 25, this much is 18, so the difference is 7. So once again, 7 would be the height on this rectangle down here, okay? So that would be another way to do it. The method that I prefer, and it's just my taste, is I like to imagine this is a whole box. So then I would have area is equal to, and my length and width, or base and height, length and width, base and height, pretty much the same idea, aren't they? So my base and height, depending on how you're looking at the figure. Okay, 35 multiplied by 25, and I get 875. Okay, so that gives me the area of a whole rectangle, all of it. But we're not looking for, we need to get rid of this space right here, right? That space is not included in this area. It's not a part of the question. So I need to get rid of that. So instead of finding all the shapes and adding together, this one I'm finding a whole shape, and then I'm going to subtract part of it from it. Okay? And the part I'm subtracting is going to be 18 by some number here. Well, if the whole length right here is 35, I need to get rid of part of it. So I need to get rid of 8 on this side and 8 on this side. Well, 8 plus 8 is 16, so 25 minus 16 gives me 19. Okay? So, give me 19. Gives me 9. Where did I get? Oh, because that's supposed to be 35. Huh. Like, wait a minute. Okay, so it is 19. Okay, done too much math today. All right, so this is 19. So then I have this square has a measurement of area is equal to 18 multiplied by 19, which is equal to 342. Okay, so what I would do then for the total area, because I need to find the total area, I would take 875 and subtract 342, and that would give me 533 feet squared. Okay, so there's the answer for that one in that method. If I did this method, I have 8 multiplied by 25, which gives me 200, and I have 200 here, and then I have 19 multiplied by 7, which gives me 133. Okay, so, and I would still come up with 533. Okay, and then if I did the other method where I do this part right here, 18 and 8, I'm still going to come up with 533 as my area. So regardless of how I solve it, if my principles and my methods are correct and solid, then I'm going to get the correct answer. Okay, we're not doing these. Okay, so this one right here. First step, I need to get rid of this odd shape that's just sticking out here. Not get rid of it, but isolate that, right? Make that its own shape. And I can make that into a triangle. Now I have 2 identical trapezoids here now. And the side, the base one of this trapezoid is 9.2. So that means that this one is also 9.2. Okay? So now I have the base and the height of this triangle here. So what I could do here is I could solve for this trapezoid and then multiply it by 2 and then add that, and that would be my answer. Or I could create another triangle, find the area of this triangle and then this rectangle, and then add the 3 together and find the area. In my work with some of you today, I've discovered that you kind of prefer this method. You don't really like that trapezoid formula. I understand. It's kind of new to us, and it's a new idea, kind of. So if you like to do this, let's do this one, okay? So my area of my first shape, I'm going to do this one, okay? That is 1/2 of the base of it doesn't matter what order we put them in, right? 9.2 and 5. And I get a 46. 1/2 of 46, and that is 23. So my area for this triangle is 23. So now let's find this triangle, okay? Well, first thing I need to do, opposite sides are equal. So that means the base of this triangle, right here, is going to be 14. So let's write that over here. Area is equal to 1/2 of the base, which is 14. So now I need to find the height of this triangle. Well, the total height of this whole shape and the base 2 of the trapezoid that we just cut through was 14, right? This length is 14 for the whole thing. But I don't want the whole thing. I only want from here to here. So how am I going to find that? Well, there's where that difference comes in again. So I need to find the difference between 14 and 9.2, right? That's what this is the difference between 14 and 9.2. So 14 minus 9.2, sorry, and I get 4.8. So my height here is 4.8, okay? So let's 4.8. And that is equal to, let's see, half of 14 is 7 multiplied by 4.8. Now you don't have to type all this in. As you can see, I just put the numbers in and put the answer, but I'm solving it at the same time. So, okay, so then we have 7 multiplied by 4.8, which is 33.6. Okay, so there's that area. So now I've got 2 of the areas that I need. All right, last one. Let's use green. Green's my favorite color, so we're going to use green. Okay, so now we're going to find this area. And I've got a base of 14 and a height of 9.2. Area is equal to 14 multiplied by 9.2, which is 128.8. Okay. Lastly, my total area is 128 point, oh, whoops, wrong circle. This one should be down here. Okay, 128.8 plus 23 plus 33.6. And that gives me, let's see, 4, 3, 6, 14, 15, and let's see, 3, oh, that should be right there. 3, 4, 5, 6, 7, 8. Okay, I did something wrong. Apparently I cannot add that way, right? Let me, and then we have 33.6, and oh, so let's add those first. 14, 8, 12, 6, and 1. 23. Okay, remember this is a decimal, so we're going to do that. Okay, 4, 5, 8, 1. That's why, because I knew it wasn't that big. There it is. I forgot the decimal. That's where I messed up. Okay, so my answer, my total area is 185.4. Okay, all right, last one, and let's see, let's do purple. Okay, I am going to take this, and I double check this so I know that you can do this, is I can just put this over here, and I'm going to make this a rectangle with a height of 60 and a base of 83. Okay, so a height of 60 and a base of 83. So then I would just multiply those and you get like 4,000 something, right? Equal to 83 multiplied by 60 is equal to 4,000 and some number. Okay. But to double check that theory that I thought that this was the same as this missing piece over here, what I did was I actually did this. And I found this height. So remember, opposite sides are equal. So this is 83. And I need to find this difference. The difference between 60, which is the whole height, and this part down here that I'm not going to be using to find the area of my parallelogram up here. And that is 60 minus 42, which is 18. So I have a height of 18. Okay, so I could do, I did area is 18 multiplied by 83. And I got like 1,400 and something. So then I did area of this rectangle down here, which is 42 multiplied by 83, which gives me 3,000 and something. Something, something, something. That's not the actual numbers. Okay. And I verified that the area was the same both ways. So I was able to conclude through my trial that this piece, in fact, can fit right here, and you can just solve this as a rectangle. So your whole goal in doing this assignment is to realize that you can break up composite figures into separate shapes that you can solve. Okay, so that's my challenge to you, is try to discover the shapes within the composite shapes that you can solve area for, and be able to glean or understand or find those missing lengths or heights or bases based on the other information in the shape. I hope that this helped a little bit.